When we create ternary ionic compounds, so much of the rules are exactly the same for binary ionic compounds. It's one positive cation hooking to one negative anion, crisscrossing charges to create electrically neutral compounds. The only difference now is that we have more players on the field. With binary, we took one metal, hooked it to a nonmetal. A metal to a nonmetal, one of each made a binary compound. Now, more players on the field, we take a positive ion, and not only can we create a binary, but we can create a ternary by hooking those positive ions to these negative polyatomics. A ternary ionic compound contains 3 elements, at least 3, sometimes more, but 3 elements by definition. But still only 2 ions. All the rules still apply. Looking up charges, crisscross, all the rules apply for making an electrically neutral compound. Still one positive hooked to one negative, but some of these will be polyatomic ions, giving us a compound that has more than 2 elements. Let's take an example. Let's write a formula for lithium nitrate. Notice right away I hear an 8, lithium nitrate. Start with the first name, lithium. I look up its symbol and its charge. Lithium is Li, carries a +1. Nitrate, ATE, tells me polyatomic ion. I start skimming through the list for nitrate. This is why it's so helpful to start recognizing names. Nitrate. Here it is, polyatomic ion. It's NO3, carries a -1 charge. A +1 and a -1 is electrically balanced. The formula for lithium nitrate is LiNO3. Still just say the names of the 2 ions. Li is lithium, nitrate is NO3, +1 -1 create an electrically neutral compound. Sometimes we need to take more than 1 polyatomic ion to balance the charge to 0. If this happens, we place the polyatomic ion in parentheses and the subscript outside of the parentheses. Let me model that. We're going to write a formula for aluminum carbonate. Here the ATE ending, polyatomic ions end in ate or ite. Find the first name, aluminum, its symbol and charge. Aluminum is a +3. Aluminum with a +3 charge. Carbonate. Again, go to the polyatomic ion. The 8 ending tells me polyatomic. Carbonate. Here it is. Its formula, CO3, and carries a -2 charge. A group of atoms acting as a unit, carrying a charge. A ternary compound has 3 elements, but it's still only 2 ions, a positive hooking to a negative. And this time we can clearly see a +3 and a -2 is not a 0 make, so we'll need some subscripts. Crisscross. Bring them around and down. We can see that the 2 gets placed after the aluminum. And to take more than 1 polyatomic ion, place it in a parenthesis and put the subscript outside. Never, ever, ever change the subscript on a polyatomic ion, or you've changed its identity. This is how we would read this formula. Al2, parenthesis, CO3, taken 3 times. Al2, CO3, taken 3 times. Aluminum carbonate. Let's try letter E, ammonium sulfate. Ammonium sulfate. Find the first one, ammonium. He's on the back as well. He's our positive polyatomic ion. Ammonium, a group of atoms acting as a unit carrying a charge. Here's ammonium, NH4, carrying a +1. The last name, sulfate. sulfate, a group of atoms acting as a unit carrying a charge. It's SO4 and it's a -2. SO4 is a -2. Clearly, a +1 doesn't balance with a -2. We'll need some subscripts. Crisscross, I'll need 2 units of my positive polyatomic, and you may place this in a parenthesis and put a 1, but we would not have to. That subscript 1 is assumed and not necessarily needs to be written. So ammonium sulfate, most commonly written, NH4 taken twice, SO4. Ammonium sulfate, NH4 taken twice, SO4. Let's try another. Calcium hooked to phosphate. Find the first name. Calcium is an element. It's on the first side, right here in group 2A. Calcium's symbol with charge is Ca+2. It's hooking to phosphate. Here the ATE signaling polyatomic time. Phosphate, PO4, 3 negative. Phosphate is a group of atoms acting as a unit carrying a charge. Let's grab that. PO4, and it's a -3. We'll need to crisscross. The 3 comes down for the calcium, and inside a parenthesis, and outside places a 2. Crisscross, bring them around and down. Ca3, PO4, taken twice. Calcium phosphate. One more together. Beryllium carbonate. Beryllium, right here in group 2A, Be with a +2 charge. Here the 8 ending, 8 and ite signal back of our periodic table. Oops, what were we looking up? Carbonate. Carbonate, groups of atoms acting as a unit carrying a charge. Carbonate, CO3, -2. We have a +2 with a -2. Already electrically balanced, no need for subscripts. BeCO3, beryllium carbonate. Pause the video, and I want you to work ahead on these practice problems. 1, 2, and 3. Do them all. When ready, turn the video back on to check your work.